For decades, clinical psychology treated a person's inability to start a spreadsheet and their inability to hold a conversation as two completely distinct flaws. If you constantly missed deadlines, you lacked discipline. If you couldn't read the emotional tone of a room, you lacked social skills. Rotating the perspective reveals a single, unified foundational structure. Both task management and social behavior emerge from this shared architecture, executive functions. A 2026 comprehensive review in the Journal of Psychiatry and Neurochemistry Research maps this connection precisely. The paper argues that chronic procrastination and severe social friction are twin symptoms of a single underlying breakdown. That underlying structure is the brain's executive function network. This is the top-level regulatory system responsible for translating long-term goals into immediate actions. When this network operates correctly, an individual can concentrate through boredom, reliably track multi-person conversations, and adjust their tone based on unspoken social cues. They appear organized and highly empathetic. To understand why this system fails, we have to map the specific neuroanatomy of executive dysfunction. We need to look at how localized chemical deficits create massive network gridlock, eventually forcing the brain into a state of toxic, perpetual stress just to get through a normal day. Mapping this biological breakdown provides a framework to trace how cognitive failure in the office translates into conflict at home. The modern clinical understanding of this architecture begins with the Miyake-Friedman model, which proves that executive functions are not a single unitary block, but a collection of distinct, measurable subschemes. Two of the most critical are working memory, the active capacity to hold and manipulate complex information in real time, and cognitive flexibility, which is the mental agility required to suddenly abandon an old strategy when the rules unexpectedly change. But evolutionary psychiatrist Russell Barkley identified the absolute prerequisite for those two functions to operate: inhibitory control, or behavioral inhibition. It acts as the brain's internal braking system. When an external trigger hits the brain, inhibitory control creates a gap in time, a microscopic cognitive pause. Without that pause, the brain has no space to spin up working memory or engage cognitive flexibility. You react impulsively to whatever is in front of you. Executing this cognitive pause relies on the physical coordination of massive brain-spanning neural networks. The first is the default mode network, or DMN. This system activates when we rest. It generates internal narratives, daydreams, and worries. The complete opposite is the task positive network, or TPN. This network firmly engages when attention is directed outward to execute a specific physical action or solve a problem. Normally, these networks are anti-correlated. The salience network routes power, suppressing the default mode network, so the task-positive network engages. In ADHD, this switchboard fails. The salience network short-circuits. The brain tries engaging the working network, but cannot shut down the daydreaming network. The behavioral result is absolute cognitive gridlock. A person sits down to start a boring spreadsheet, and their conscious awareness is violently flooded by irrelevant thoughts, internal dialogues, and anxieties. The mental noise makes action impossible. Chronic procrastination here is a direct, observable symptom of structural pathology. The brain is quite literally incapable of suppressing the DMN. For the salience network to operate, the prefrontal cortex requires continuous, sustained levels of chemical catalysts, specifically the neurotransmitters dopamine and norepinephrine. When anticipating a reward, a healthy brain releases a dopamine spike that provides the activation energy to start working. But the ADHD brain suffers from ventral striatal hyporesponsiveness. When faced with a distant, unrewarding task, the brain generates absolutely zero dopamine. Dopamine dictates motivation, but it also serves as the physical calibration mechanism for chronoception, the brain's internal perception of time. When dopamine levels drop to a critical low, the internal clock physically grinds to a crawl. 10 minutes spent reading a dry textbook feels like an agonizing eternity. This temporal distortion creates temporal myopia. The brain loses the ability to emotionally connect with the distant future. A critical deadline 2 weeks away registers exactly the same as a deadline 2 years away. It simply does not exist in the immediate environment. If the brain cannot perceive time accurately, and it lacks the dopamine required to initiate an unrewarding action, the individual is trapped. To survive, The brain utilizes a highly toxic, unconscious biological workaround, the adrenaline bridge. The individual waits in a state of paralysis until the deadline is just hours away. Suddenly, the temporal threat becomes real.
This massive, undeniable perception of failure triggers the sympathetic nervous system's fight or flight response. The body violently floods the dormant prefrontal cortex with acute stress hormones, cortisol, adrenaline, and norepinephrine. This emergency surge artificially supplies the brain. It narrows focus, completely blocks the hyperactive default mode network, and allows the individual to execute a frantic, superhuman all-nighter. The lying on this panic cycle carries massive physiological costs. Constantly flooding the nervous system with cortisol degrades immune function, spikes cardiovascular risk, and guarantees eventual, total occupational burnout. The adrenaline bridge ensures the essay is submitted by dawn, but it traps the individual in a permanent, corrosive state of physiological survival. The exact same neurobiological breakdowns that paralyze work execution actively dismantle social adaptability. Time blindness and perspective memory deficits do not isolate themselves to office spreadsheets. They guarantee forgotten birthdays, showing up an hour late to important dinners, and constantly dropping the small promises necessary to maintain a romantic partnership. Neurotypical individuals logically interpret these constant failures as a profound lack of respect or empathy. The resulting social friction is immediate. To measure this friction empirically, Maya and Heider utilized a methodology involving classic neuropsychological tests, like the Stroop color and word test and the Wisconsin card sorting test, strictly isolating individual executive functions. Predicting procrastination severity, inhibitory control emerged as the strongest independent predictor. This confirms the Barkley model. Lacking the neurological brake directly causes the failure to initiate a task. But when predicting peer-rated social adaptability, a completely different metric took the lead: cognitive flexibility. Cognitive flexibility is the mandatory biological hardware required for theory of mind. It's the capacity to drop your own viewpoint, process a subtle emotional cue, and shift your perspective to understand a friend's completely different worldview. When an individual relies on the adrenaline bridge to survive their workload, their brain is saturated in cortisol. A brain locked in fight or flight possesses zero cognitive flexibility. The prefrontal cortex is too depleted to inhibit emotional reactions, turning minor social disagreements into volatile relationship-ending arguments. This compounding friction frequently triggers rejection-sensitive dysphoria, an extreme physical emotional pain generated by an enlarged, hypervigilant amygdala in response to perceived criticism. Faced with the deep shame of chronic unreliability and the agonizing pain of rejection, the amygdala categorizes social interaction as a massive threat. It forces the individual into profound isolation as a strict protective mechanism. Chronic procrastination is an occupational hazard, but the underlying executive dysfunction that drives it actively severs human connection. Generic productivity advice fails because telling someone to just use a planner completely ignores the structural gridlock inside their brain. In clinical psychiatry, there is a strict axiom: pills don't teach skills. Stimulant medication is often necessary to repair the baseline chemical shortage of dopamine, but it cannot automatically unwire decades of heavily myelinated avoidance habits. Rebuilding function requires highly specialized cognitive behavioral therapy, designed specifically to target executive dysfunction, utilizing protocols like the Solanto and Saffron models. Mary Solanto's technique relies on extreme task A construction. By shrinking a project down to a completely microscopic first step, like merely opening a blank document, the task becomes so small it sneaks past the amygdala's hypervigilant fear response. Saffron addresses the gridlock directly, using physical distraction logging to manage the intrusive default mode network. Writing an intrusive thought down on a physical notepad completely externalizes the impulse. This satisfies the salience network, acting as a physical brace that pins the daydreaming network down, finally allowing the task-positive network to engage. These therapies strip away generic emotional processing. They act as literal external neurological scaffolding to compensate for a prefrontal cortex that cannot support its own weight.
By directly repairing the underlying executive architecture, this clinical approach solves the occupational paralysis while simultaneously rebuilding the cognitive flexibility required for empathy. Treating procrastination as a moral failure ignores the biology of behavior. Recognizing it as a measurable network failure allows us to actually repair the hardware, restoring both a person's life trajectory and their capacity for connection.